Hello students, I am here again for the derivation of first law of motion and second law of motion mathematically from the chapter Force and Laws of Motion. So let's begin. Hello students, we have a new chapter that is Force and Laws of Motion. So in this video we will be deriving the first law of motion, then after second law of motion, all mathematically. We have some formula here upon this laws. So that formula we will be deriving in this video. Okay. So before deriving this one, we need to know some of the components, that is momentum. That is symbolized as P, and its formula is mass into velocity. That means the final velocity, that is P is equal to mv. So this is the formula for momentum, P equal to mv. So when we have the change in momentum, if I say change in momentum, that means it will become v minus u. So this is the change in momentum. What was our formula? P equal to mv, mass into velocity. So velocity, if I take the change in momentum, the change in momentum will be takes place with the change in the velocity. So change in the velocity will be v minus u. So this is the formula, exact formula for momentum. P is equal to mass into velocity. And if we write the change in momentum, so it will be focused as P equal to m v minus u. So these two formula we need to know before deriving the two laws of motion. We will first derive the second law of motion mathematically. You know already that second law of motion is the rate of change of momentum. Rate of change of momentum of a moving body. Is directly proportional to the applied force. Okay, so this is the second law of motion, and this is the statement for second law of motion. But now here in this question we have to state the second law of motion mathematically. Okay, so if we derive the mathematical portion of second law of motion, then it will have a formula, that is force is equal to mass into acceleration. Okay, this force will be equal to mass into acceleration. So this formula, that is in short form we can say that F is equal to ma, m for mass and a for acceleration. This formula we have to derive mathematically for the second law of motion. So instead of second law of motion, if mathematical portion we have to write, that we need to write the formula F equal to ma. So how it has came, that we will be deriving now. So according to second law of motion, what it states, rate of change of momentum of a body is directly proportional to the applied force. So we can write, instead of this statement, force F is directly proportional to the applied force, or applied force is directly proportional to the rate of change of momentum. So rate of change of momentum. Okay, so our next step will be F will be equal to, if I write the formula for rate of change of momentum of a moving body, that is momentum formula. So momentum has a formula, momentum m is equal to m into v, and momentum is symbolized as p. So p equal to m into v, m for mass and v for velocity, final velocity. So if I write here change in momentum, change in momentum will be m v minus u, where v is final velocity and u is the initial velocity. So that is the formula for change in momentum. So here rate of change of momentum has came here. So rate of change of momentum means the change of momentum is taken place with respect to time. So we can use here divided by time, and now we have already the formula m v minus u by t. So if you remember the formula for acceleration, so acceleration formula was v minus u by t. So instead of v minus u by t, I am writing here a. So in order to remove the direct proportional symbol here, so I need some constant term. So using that we can write k equal to k ma, f equal to k ma. Okay, so where k is some constant. So if k value is 1, so we can write f is equal to ma. So this is our derivation for the second law of motion mathematically. So how I have taken this k equal to 1? So let us take the example. Suppose if force is equal to 1 unit, if mass is also 1 unit, and acceleration is also 1 unit. So using the formula whatever we have got, f equal to k ma, so we are getting here f is 1, k, m is also 1, and a is also 1. So what we are getting now, k will be equal to 1 unit, and so that 1 unit I have placed here, and then after we have got f equal to ma. Okay, so I hope you have understand this one, the second law of motion mathematically, how to derive this one. Okay, we will now derive first law of motion mathematically. We are doing here derivation. This video contains all the derivation part of this chapter. Okay, so we have derived already the second law of motion. So then after we are now in the first law of motion. Second law, many of the components in second law of motions will be required here in first law of motions. So that's why I have derived that second law of motion in the beginning. Okay, so that we can easily use the components whatever formula we have got in the second law of motions, or simply we can say that the formula that we have got in second law of motion, from there we will start our first law of motion. Okay, so if I go towards the statement, so this is the statement of first law of motion. This law is also known as law of inertia. Okay, so what is inertia? It is a tendency of a body to continue its state of rest or of uniform motion in a straight line. So that was our beginning sentence of first law of motion. So it will remain in a state of rest or on a uniform motion on a straight line unless an external force will be applied in that object. Okay, so that's why it is also known as the law of inertia. So let's derive this one mathematically. Okay, so for derivation we need the second law of motion in the beginning. Okay, so second law of motion, according to second law of motion, what we have got mathematical expression for second law of motion, just now we have derived, that is f is equal to ma, where F was applied force, and then after m was mass of the object, and a was the acceleration. So if I use the next step here, so m mass, so in place of a acceleration, we have got the formula a is equal to v minus u by t that I have discussed already. Okay, so this one I will place instead of a. Okay, so now when no force is applied, that means the body is in the position of rest, or it is moving in a uniform motion still now. Okay, so when no force is applied, then our F will be equal to 0. So now in this equation, if I place in place of F 0, then how it will be? U by t. So the next step will be, if I send t here, so it will also multiply it with 0 and it will become 0. So it will remain mv minus u equal to 0. So next will be, if I send mass there in the right hand side, so it will become 0. So mass will never be 0, you understand that? Okay, it is that situation that we need to describe our first law of motion mathematically. So here in the equation, mass is becoming 0, so that's why mass will never be 0. Okay, so we are assuming only for the equations, for deriving the equations. Okay, so now if I send mass there, it will become 0. So v minus u will be equal to 0. So now our equation will be v is equal to u. So what we are getting, that final velocity is always equal to initial velocity. Okay, so thus this means that the body will continue. The body will continue in a position of rest, or it will be moving with a uniform acceleration, or you can say uniform velocity throughout the straight line. Okay, until a force is applied to it. Thus our first law of motion has been proved, that unless an applied force, external applied force, will be applied on it, on the object, the body will not move from its own position. Okay, it will be continue in moving with a uniform velocity, or it will be in the position of a rest. Okay, so I hope you have understand the two laws of motion. We will meet again in the next video. Till then, you see these things, you see the videos, and you try to understand. Okay, thank you and take care.